we're live. My name is Robert Ronan, and I'm a Principal Product Manager here at Oracle, coming to you from Austin, Texas. For today's workshop, we have Laura Santamaria, Developer Advocate with Polumi. And on the Oracle side, we have Rahul M.R., Senior Solutions Architect at Oracle. If you've got any questions today, please put those into the Q&A area, and we will answer those as they come in. And with that, let's kick things off and get this workshop started.
Welcome to the workshop. My name is Laura Santamaria, as the intro said, and I'm a developer advocate here at Polumi. I have Rahul here with me and a few other folks here on the call from Oracle, but in general, I hope y'all are excited to be here. I'm excited to be here as well. We're going to do a little bit of an introduction to infrastructure as code and how we would do that on Oracle Cloud with Pulumi and Python. First things first, I love having interaction in the chat. So I hope y'all feel comfortable typing, talking to me through there. I try my best to discuss back and forth. How many people are familiar with infrastructure as code? If you can just leave a note in the chat, let me know how familiar you are with infrastructure as code, and we'll just the basics. Folks are new. Excellent. I love having new people here. So I think we'll probably have a lot of various people talking about infrastructure as code. So again, I'm Laura, and I've been doing infrastructure for various companies now for a little while. I've obviously been doing a lot with infrastructure as code with Polumi and talking about cloud engineering as well. And so one of the things to know about infrastructure as code is that it enables us to build out infrastructure in a repeatable and reliable fashion so that we don't end up with handcrafted infrastructure that we then end up with problems with, because let's say that maybe one person set it up one way, someone else set it up another way, and it doesn't work anymore. Or you have scenarios where maybe you're doing some testing or you need to have staging up and running, and it doesn't match production. And so these are some of the reasons that you actually want to use infrastructure as code. That repeatable, reliable experience that you have with infrastructure as code ensures that everything always goes up the same way every time. And you can start to understand if, for example, someone goes in and changes the settings on your networking, you actually can detect that with infrastructure as code and understand what might have happened so that you can roll back to a known good configuration and continue to build from there. So that's some of the reasons that IAC is really helpful. Now, I'm a little biased, as you might guess, that I prefer to use Polumi, mostly because I really like Python. I've been a Pythonista for a very long time, and it's just something that I know well. With other systems, maybe you have to go through a whole bunch of new experiences and new things to learn to be able to actually build your infrastructure. But in this case, all you have to do here is learn about infrastructure, or because you probably already know the programming language, or vice versa, perhaps. But it's a really great experience to be able to do that. So before we begin, I have just a couple of little housekeeping notes. Again, I absolutely love discussion in the chat. I try to respond to you. I know we also have a lot of people on who are going to be able to help you in the chat as we get into the actual meat of the discussion here. But if you want to toss me a question or anything in the chat, this is what makes it a live workshop versus just a recording you're watching. And so I really would love to have that interaction. You can also join our Slack on Polumi.com. So slack.polumi.com, and head over to #workshops. If you're watching this later and have some questions, you can pop in there and be able to go have a discussion with me about it. Or if you're just watching right now and talking with me, and then you want to actually go try the code later, you can do that as well. I do have a follow along, which I'm about to drop here in the chat. It's fairly bare bones because I do enjoy showing you what we're doing rather than having you just walk through it while I'm talking. So if you would like to follow along, you're welcome to. We do have all the code in there. And again, feedback is always welcome. I would love to find out what you think about this workshop as we go along. So with that in mind, we talked a little bit about infrastructure as code, but really when we get down to it, infrastructure as code is the idea that you are taking your infrastructure that you might want to deploy, and you are writing it up in a regimented fashion in a programming language or a configuration language or something along that line, DSL. There we go, domain specific language. So you're writing it all out in a way that other people can audit. So you actually can put it into source control, which is wonderful. You can test it. You can make sure that everything's always going to stay up the same way. And you can always ensure that, say that you need to hand it off to somebody, we don't have that issue of only one person understanding how this works. If you're familiar with the Phoenix project, there's the word I'm looking for. If you're familiar with the Phoenix project, this is the case of no more Brents. You don't have one person who knows how everything works. Instead, you have a code base that everyone can read and learn from, as well as ensure that they can also stand up the same infrastructure that you do. Pulumi's approach to infrastructure as code is really focused on cloud engineering, which takes software engineering principles and applies them to your cloud-based infrastructure. So that ensures that you don't repeat yourself. So that's dry, ensuring that you can abstract away code. You can do classes if you're using object-oriented programming languages, etc. I find it's really helpful when you're trying to build all of that out, because you can kind of write it the way that other people are going to understand. So that's kind of the short version of infrastructure as code. With that in mind, I want to talk a little bit about Pulumi's model. Now, this can be found on the Pulumi docs in the architecture and concept section. Pulumi thinks about things and thinks about your infrastructure in terms of projects. So when you actually have a specific piece of infrastructure, you're thinking about it in terms of the application that maybe is running on top of it, or something similar to that, something similar along that line. The project itself is, you can think of it as the overall box that all of your infrastructure stands up in. And that project on your machine is going to be a folder or a directory. You can use either one interchangeably around me. It's okay. It's going to be a directory that holds all of your program and any other information around your stacks, which we'll get to in just a moment. Now, a project can also be obviously committed to source control, so you can monitor it and modify it from there and ensure that other people can pull it down. The program is the actual code. So that's the, in our case, it's going to be dunder main dunder.py. If you are running TypeScript, I forget the name of the file, C#, JavaScript, any of those, Java, it would be the main application file itself. All of that is the program. So when I use project and then I use program, I'm using them very deliberately. Inside of your program, we like to talk about cloud resources. So these are the actual individual components that you're building. And inside those resources, we have inputs and outputs. So the inputs are the bits of configuration that you're passing in. So you might have an ID that gets put in for a specific resource, or maybe you tell it that what we'll see is with our actual instance that will stand up, we can talk about what VM type it is, or how many gigabytes it has in memory. Those are all inputs into a resource. Outputs are what happens when the resource itself gets provisioned, and what do you get from it? So we'll see in a little while, when we actually stand up a Kubernetes cluster, we can actually get the kube config from that Kubernetes cluster as an output, and we're going to use that to be able to actually access the cluster. You can pass outputs to another resource, so that one resource, let's say a VPN, is created and it has an ID. That output can then be transferred to a subnet that's actually able to access the VPN. So it uses that output of an ID to be able to make that connection. So that's really what this diagram is trying to show you. Along with the resources inside the program, you might have different providers, which we'll talk about. So like, let's say you're running Oracle, and then you want to add Datadog. Both of those are different providers that you might actually want to use, and each provider adds different resources. Alongside the program in your project are stacks. You might know these as environments. So you might have your dev environment, which is where we're going to start today. You might have a staging environment, a QA environment, production, any of those things. The nice thing about having stacks is that you can continue to stand up the same program with different inputs, so different configuration values that go in to be able to say, this is staging and this is prod, or this is dev and this is QA. So you can tell all of the differences from there. So that's Pulumi's model, and that's what we're going to be talking about today as we start to build out this actual infrastructure. I know y'all didn't really come to hear me talk at you. Let's actually go and build something. So we're going to get started here. And I did take the liberty of already creating my directory, which is going to be my program. So in my case, I've got OCI-workshop-July 2022. Polumi itself is a CLI. Polumi, there are other languages for Polumi that aren't Python. There's TypeScript, JavaScript, C#, Go, Java, and we do have a YAML provider as well now, if you want to just kind of start somewhere basic and then eject out to other programming languages. Today, we're going to be using Python, though. So mostly because it's probably the best one that I know, and it's pretty available. How can output be shared between projects? That's a great question. We're going to get a chance to see this, but the short version is that you can take an output and tell the stack to actually export it, and then you can consume that as a stack reference in another project. So you can go from project to project and start doing it. So it would actually, and I'm just going to make this a little bit bigger so you can see it and clear. And so it would look something like, if we were imagining what the stack reference would look like, it would have the project and then the stack and then the actual reference or the export like this. So that's how you would actually call it inside of your program. It's a good question. We won't get a chance to really share outputs between projects in this specific workshop, but I know you can find it if you go to learn.polumi.com. It's the second pathway, building with Polumi. All right, y'all ready to do this? Let's get started. So Polumi itself is partially a CLI and partially an actual engine. So we call that the Polumi service. The engine actually takes care of your state file. And I just realized I didn't explain state. So let me backpedal a little bit because I missed that part in the actual presentation part. The state is the information about what's currently happening with your resources. So that's how infrastructure as code is able to tell what's supposed to happen, what's currently going to go on. Polumi, like other tools you might have used, is declarative. So it just says that we want to declare what the end state is, which is what we're about to do with our programming languages. We're going to tell Polumi, this is what I want my end state to be. I personally prefer to call it a desired state infrastructure as code tool versus declarative, because I think that gets mixed up with people's concepts of programming languages. But the short version is that Polumi keeps track of the state of the resources that you're provisioning. So are they currently running? Are they not running? We'll get a chance to see that when we actually run Polumi up, which is how we stand up our resources. Is Polumi similar to Terraform by Hashicorp? It is a similar project, yes. Both of them are declarative or desired state. Both of them allow you to work with various providers. Polumi is a little bit different in that we can actually use programming languages, which is probably one of the big ones. We have a few other things that go on. You don't have to manage state. We'll get a chance to see that you don't need Vault or things like that to manage your secrets. Instead, you're actually going to be managing them in Polumi, and it kind of locks everything up that way. There's a few others that have some differences. I'm happy to share, there's a YouTube video that we have up that really explains that from the point of view of someone who's already known Terraform. I'm happy to explain those to you then. It's an alternative. So in answer to the question, yes, it is an alternative to Terraform. It kind of depends on what your use case is and what you're trying to do. Again, I might be a little bit biased, just a little bit. But I do think that Polumi has a lot to offer that I think is worth exploring. what we'll get a chance to see is that Polumi is using what's called the Terraform bridge for OCI specifically. Some other providers we actually have native integrations for because they gave us access to their APIs. So Datadog, I think our Datadog provider is a native API. There's a couple like that where they instead wrote their own provider to connect to Polumi that lets us connect directly in. The Terraform bridge was built before a lot of cloud providers had APIs, just to ensure that we could actually access different tools. So it's a community run project, and we build on top of the same bridge on occasion. So in this case, we certainly will. But that being said, you get a chance to use your programming languages with it, which is really wonderful. And we manage state for you, secrets, etc. So hopefully that gives a very quick overview. Not everybody here, I imagine, knows Terraform. So I'm trying not to go too far into that difference, but if people are really interested, I'm happy to start discussing that after the workshop is a little bit over in the Q&A. Cool? Cool. Let's go back to standing up our infrastructure. So Polumi has an init function that lets us actually start, Polumi new. I keep doing this today. And in this case, we actually have access to a lot of templates. In our case, we are just going to do Polumi new Python. I can certainly go through and choose a whole bunch of different templates that we have available, and there's new templates coming on every day. But in this case, we're going to start from scratch because I want you to see how we build this up and why I do, at least, what I do to build all of this infrastructure up. So we're going to do Polumi new Python. It's because I already have this open in IntelliJ in PyCharm. So it's asking me, because if we take a look, normally you're supposed to have an empty directory. So if you ever run into this, it's because you've already opened it in something that maybe added a directory. In this case, I have a .idea file. So I have to run -- force. I always forget I do that. So the command actually walks you through how to create the project. So in this case, I'm going to just accept the defaults, but I want to tell you what they are. So project name is exactly what you think it is. Just as before, we have projects. This is what's going to happen. This is what's going to be remembered in the Polumi engine, in the Polumi service. So we have that. A basic project description. This is a case where it might be really helpful for you to add in a lot of description about your project. We're not really doing much other than a sandbox here, so I'm not going to worry about it too much. And then this is the stack name. Again, this is your environment. In this case, we're just doing a development environment. I'm going to keep the standard dev, which is what we use. So it's going to create, ignore the little failed to resolve Python version. That's because I use some other things. It's going to create a virtual environment. Now with Python, it does create a virtual environment for you. We're a little bit opinionated in that sense. If you're not familiar with Python, virtual environments are really, really important because they ensure that your local machine doesn't have a corrupted Python instance if you get into trouble when you're trying to build out a project, things like that. And it also scopes all of your downloaded packages just to that virtual environment. So we do that just to make sure that when you're going from project to project to project, you're not dealing with a lot of chaos because maybe you installed it on one project and it somehow ends up on the other, but it's a different version, etc. This allows you to make sure those are compartmentalized. So here we are. And we have some initial pieces that are going to get added. And that's going to be our .gitignore because we expect you to end up on version control with these. .idea is that directory that came from before that comes from IntelliJ. Polumi.yaml, we'll get a chance to see what that is, but the short version is that's the metadata for your specific project. Dunder main dunder.py or double underscore is dunder in Python. Dunder main dunder.py is the actual program that we're going to be running. Requirements.txt is a Python system thing that actually has all of our different dependencies in there, which we're going to be updating in a moment. And venv is our virtual environment directory. So enough about looking at this. Let's go. And here we are in my workshop file. Come on. Whoops. There it is. Okay. So we're going to open up. All right. I'll keep an eye on the chat, but go ahead and leave me questions. All right, so let's take a look at some of these files real quick. I promised we would take a look, and let's make this just a little bit bigger. There we go. I promised we would take a really quick look at our Pulumi.yaml file. We're going to see that when we actually deploy this, we're going to get a separate file for our stack configuration. But for now, we just have this name information, which is the name of the project, the runtime, which is in our case Python. If you were doing TypeScript, it would say TypeScript. If you were doing Java, it would say Java. And then there's some options. In our case, the only option we have is that virtual environment that comes up. And then a description of the actual Polumi program. So how does it connect to your OCI tenancy? Does it have to be pre-configured? We're about to go into configs in a moment. And this is just to connect to Oracle DB or for implementations. This is going to actually stand up all of your Oracle infrastructure. So we're going to get a chance to see what that looks like. Hopefully that's going to make a little more sense in a bit. Woo, lots of questions today. I'm integrating both. Okay, Tyrell, I think that's going to be a question for the Oracle folks. And manage services to run Polumi instead of using the CLI. Not yet. Keep an ear out. Hopefully soon, maybe, possibly. I can't promise anything. Okay, let's kind of go in here. We're going to just add a different piece of requirement here. In this case, we want to add our Polumi OCI. And I'm bringing up there we go. Okay, so we're going to add Polumi OCI. And we're going to save this. I use Vim key bindings. I'm sorry in advance. I know that annoys some people, but that's just how we're going to do it here. So let's open up our terminal. And we're already in our virtual environment because this already gets initial. Oh, no, it doesn't. Source, VM, bin, activate. If you were not running this from here, you'd actually discover that it already has the correct Python environment going. And so we're just going to update our requirements real quick. And all that does is just make sure that Polumi OCI, the Polumi OCI package that lets us connect to Oracle Cloud is already on here. So let's clear that. And now for the fun part, let's actually go build something. So in this case, I'm just going to import Polumi, and if you're following along on the actual workshop repo, you'll find that we're on part 1, which is the dunder main dunder.py from part 1. So I'm going to import Polumi OCI as OCI, and then we're going to start doing some things here. We are going to set up some configurations in just a little bit, but you can pull all of those configurations into the into your Polumi program so you can reference them as variables, which is going to be something that we're going to find really, really helpful as we move along, because that compartment OCI, that's going to actually be a secret that we're going to configure here. So, and we'll get a chance to do that in just a moment so we can actually configure those. And all right, we're going to add some networking in here because whenever you have various pieces, you want some networking to go in with it. So the nice thing, if you're noticing, I'm getting all of my information here about the various VCN, the various autocomplete that I can do from any kind of package. So if you're familiar with IDEs and are very comfortable with them, you're going to see this and be really excited because you don't have that issue where you don't necessarily know what's going on here. Oh, I know why. This is on the wrong interpreter. Excuse me 1 minute while I go fix my interpreter here. Since it's not pulling the right one and you're not getting the same type hints that I get, it's using a different one. And you're going to see that I have way too many interpreters running. There we go. Okay, so now it's going to be actually updating all that information while I'm actually typing here. So right here, we're about to give it some information. If it wants to type with me, this is our inputs, or these are our inputs that I'm actually entering in. There's always a name. This name right here, that's in just a simple string, is what Polumi sees. This is the Polumi name, so that we're able to track your various resources. CIDR blocks. I can type and talk at the same time. That's going to be the fun part here. 10.0.0.0.16/16. Now, this is kind of some very, very basic stuff here, but compartment ID. Yep. And that's going to be set to that compartment OCID. So this is a case where we're actually using a configuration file, setting it to a variable so that we can then call it without having to constantly retype that config require secret, config require secret, config require secret, because that gets a little old. This ensures we can just call it once and then it's available to our program without having to run that. So it'll run just a tiny bit faster when we do that. So this is just an example. I'm going to just copy the rest of the networking pieces that we need, rather than making you all watch me type. And there we go. So we just kind of copied those in, and these are OCI core. Just to give you a rough sense of what I'm looking at, this is all going to be in the registry, which we'll get a chance to take a look at, the Pulumi registry here. So if I go to registry.pulumi.com, we'll let it load, and we can actually search right here for Oracle. And there it is. So this is the information, a little bit of information about how to configure it, install it, set it all up. We are going to be walking through this Polumi configuration section. Let me make that a little bigger so I'm sure y'all can see it. We are going to be walking through the configuration section. I prefer to store everything as a Polumi configuration value instead of an environment variables. You certainly can do that. We're going to be declaring that actually in the configuration. And you know what? Since a lot of people are asking, let's set that right now. So here I am in my terminal over here, and we are in our actual Polumi stack already. You can see that right up here with dev, because I have that written into my my prompt here. And so we do Polumi config set. That's how you actually set a variable or set a configuration value. So in my case, I'm going to do Polumi config set, and we're going to do compartment OCID. I think this is the correct one. We're going to just go double check because I've been on 2 different versions of Oracle Cloud today. So I just want to make sure that I've got the right one. But you're going to find that by going into your Oracle account, going to your profile, and it should be right here. And good thing I double checked because I was on the wrong one. I just hit the little copy button and I can go in here and set that. So we're going to just real quick go set that. I'm specifically just grabbing the, or actually that was my tenancy. That was my username. Let me get the correct one because I know y'all are going to be looking for it. Where am I? Tenancy. All right. So I actually don't have any compartments on mine, so I'm just going to copy the tenancy because it should be the same one. If I'm remembering correctly. I forget. All right. So let's make sure I use the right one. Because since I'm using the same one, I'm not going to actually set it any differently. So when I run that config set, now in a moment, this will update with my dev. There it is. So this is where it's stored locally, and then this will get pushed up to our Polumi service. So there's my secure compartment OCID. I use the secure flag, which is that -- secure, just to encrypt it and make sure it goes up correctly. All right, so that's how we set those up. I know everybody's been asking that, so that's where we're going to do that. But let's get back. Let's get our code up. And I'm just going to real quick copy the rest of the code in. And we'll get a chance to take a look at these in just a moment. Oh, come here. All right. And I'm not missing anything. Okay. Now let's actually make sure we have everything else set up here. And I'm going to show you as I go through and actually add everything. You're going to discover that everything's going to get added here as we go. So Pulumi config big set, and then user OCID. And again, I'm just going to set it as secret. I don't have to, but I choose to. So this is the one thing that's going to require you to go in and out of the console, is to pull up all of this information. And we can see that's in there. And so now this should update. Come on, file. There it is. There goes the user information. And I already should have the fingerprint in here, but let's go. We'll just go get it. So I already have my API keys already built. So this is the fingerprint for my API key. Now you might be wondering, why am I going through and doing it this way versus actually, just using an environment variable? Polumi allows you to ensure that, actually, I can do this at once. Yes, you can set multiple input configs at once. I'm doing this one by one just because I have to look them all up one by one. But once we get to it, there is a Polumi config set all. There's also actually another one, which is Polumi config copy, I think. Let me double check that before we go anywhere. So there's Polumi config copy from one stack to another. When you actually do that, you can copy from one config to another stack. So you can actually go through and do that. You can find all this information on the Polumi CLI reference. So Polumi config is right here. But this is a use configuration values in a specified file rather than detecting the file name. We're not going to do that, but you can actually do the set all right down here. And this is where you can set multiple values. So you would do secret for secret values, key 1, value 1, plain text, key 2, value 2, secret, key 3, value 3, etc. So yes, you can set them all at once, which is a lot easier, frankly, than the way that I'm doing it. I mostly just want y'all to see how we're actually copying everything along. So I'm trying to remember, where was I? Tenancy. Let's actually do it this way. I know, we're going to just do, since it's the same one. Oop. All right. And what am I missing here? I've got the fingerprint. Let's go double check what I'm missing, because I always will forget something and we'll get an error. Region and the private key file. Those are the last two. Okay. So in this case, wrong one. In this case, we don't really need the region to be secret. Set region. And I'm in US Ashburn 1-1. Can you enforce secrets on certain inputs or all inputs to prevent users from ever exposing, such as a private API key? I think the best way to do that is in something called our policy packs. I'm not that good at that part, so I will 100% admit that, but I believe that's the way how you ensure people can't possibly expose private keys. Because what it does is it just requires that whenever you go to actually push something up, it double checks all of these rules against what's being pushed up. And if it's not correct, it won't let you update. So I think that will probably be the best way to go through and enforce secrets on inputs. So it still requires the user to go back and fix it. Hopefully they'll learn for next time we can hope. But you can also just double check that. So generally the secrets are really nice because it ensures that it's all in one place and you can't get it back. Like you can't get it to print to the terminal once it's a secret. You can't get it to do anything. Now you have to pay attention in your code not to print it, but even then it should print secret in brackets instead of the actual full secret. So just something to know. And then last but not least, I believe my config set private key path. Yeah, that's the same one. Okay, cool. So here we are. We've got all of our various bits and pieces. I'm just double checking myself against another config profile that I've done. And I think that's everything. So we're going to give it a shot. What we're going to do is we're going to run Pulumi up now. Pulumi up is, if you're familiar with Terraform, where you have to first run plan, then apply. Pulumi up lets you run a preview and get to see what it's about to do. And then it asks you, are you sure you want to do this? So let's see what it does. And sometimes it takes a little bit to get that initial creation going, but it tells me everything that I'm doing up. And see, I am missing a configuration value. So in this case, I have and this is probably something I really shouldn't do on a regular basis, but I do. You can actually copy from one to another as long as it's not a secret. So in this case, doop, and we're just going to change this to July 2022. Now, if I was actually to go through and do this again, it should give me not the same error, but generally the errors from Polumi are pretty clear, which is really nice. And here we are. So we've got our just a little bit of things. We have a VC and a subnet, a gateway, another gateway, and an instance. Let's take a look at the details. What does this look like? It goes through and gives you all of the information that you were expecting to see. Now, for the person who asked about secrets, note that it's still listed as a secret, even in the details. It doesn't actually give that information out. These URN are universal resource numbers, or how we actually identify our resources in Polumi. So we have the URN for the actual gateway, which you'll see is that OCI core internet gateway. If we were to go back, close that. Go back here to the internet gateway, oci.core.internet gateway. That's where that comes from. And then the provider itself is the actual OCI provider that we're calling. So the library that we're calling is the OCI provider. And so you'll see everything else is in here. Again, we have all those secrets in there and the stack. So it's asking, are we ready to update? We're going to hit yes. And what this does is it then lets us go through. Now, if you were running this in CI/CD or in a pipeline, you actually can go and take a look at the same run on your dashboard here at app.polumi.com. In this case, we're running an update and I can see it running here. So if I were to go through, and let me again make this a little bigger because I forgot to do that before we started. If I were to go through and have this running from a pipeline and I wanted to see, hey, what's going on with it? I can log on right here and see what's being created and how far we're getting along. I can get information about the timeline, what's being created when, any configuration values. Again, these are locked secrets, so they do not display on the actual app.polumi.com. Oh, look, it succeeded. We'll go back and check it in a moment. And then I can get some information about the environment that's running. In this case, it's a CLI. If we were running this with a different pipeline system, like let's just say Circle CI, because I just recently did that, it would actually say on here that it comes from Circle CI. So I would know that, oh, this wasn't one run by a person. This was one run as part of my automation. So that's just some various things there. And we can also see the resources themselves and how they're connected. The graph is really helpful to understand how things are interconnected. I don't have anything interconnected on this specific one. We'll get a chance to see that with the other one that we're going to be doing when we actually do Kubernetes. And then we have some settings here. So it just gives us some information about what the settings are. But in this case, we are already set. It provisioned, whoop, not that one, this one. And it gives me the output here. So when we're talking about stack outputs are actually kind of important because we use those to get information like public IPs. How do I access this information? So if I actually wanted it to just simply echo out that output, I can call it straight here from the command line. If I can type, that would actually help. So I can actually get it to echo out that same information. I could curl it, I could SSH into the box. I could do a lot of different things from here. Any questions while I grab a drink? Okay, no questions. So I'm going to continue onward, and we are going to do something a little bit different. So we have all of our resources up. If we were to actually go back here to check here on Oracle Cloud and bring up instances, we're actually going to see that instance all loaded up for us. Here it is. And if you recognize 129.213.29.220, again, if we echo that stack output for the endpoint, 129.213.29.220. There it is. So now we can validate that the same resources showed up as a result of Polumi. There's a question in the chat. If I am building a hierarchical resources, in that case, will it allow me to pass the output of one script as input to another? Yes. Yes, it does. So that's actually this call here. So like, for example, we have node images getting created here on line 113. Or sorry, not created, getting called, which came from this node image right here. So we're actually calling the information from that. Now, if I wanted to pass information from one stack to another, I can do that using stack outputs, and stack references, which is what someone was asking me about earlier. That's this Pulumi export. When you export it, you actually allow it to be used by other stacks. So hopefully that makes sense. All right, so one thing next that we were going to do, and I think I have it up. All right, let me just show you that you can actually create another stack, and I can actually copy my configuration from one stack to another. So if I'm going to do Pulumi stack init, and I want to create a new stack, let's call it staging. Okay, copy config from dev. Hit enter. And what this will do is it'll create a new stack. And now I'm on the staging stack. So Pulumi stack ls lets me see that I have two environments running. And if we go back here to the project, we can now see, hopefully, there it is. We have staging and dev. So obviously the nice thing is that I don't have to copy all of those configuration values from one stack to another. I just have it right here. And it's still set up that way. So I can run a Pulumi up and have a separate stack running, a separate environment with all the same things exactly as used, which is, again, the really big thing about configuration or infrastructure as code, is that it's all together working the same way every time I stand up a new stack. Now, here's a fun question for you. What would you do with that? What's like the one big thing that everybody thinks about when they think of, oh, hey, I can build up a stack exactly the same as another stack? What could you do with that? My QA folks probably are the ones who are like jumping up and down in their seat, waving their hands. Testing, that's right. So if you want to be able to stand up ephemeral environments or like short-lived environments, to be able to run a testing or to actually test your stack, you can do that now. You can do that as part of your actual pipeline. So you can, let's say you need to run some basic tests in your application, and you decide that you also want to run some tests on the actual infrastructure. You can just put that as part of your pipeline and just say, okay, as part of my pipeline, but before we actually get to, let's say, prod, let's say that your order is dev, QA, staging, prod, right? So if those are your environment orders or your stack orders in the case of Polumi, maybe you build it in dev and then you deploy it. So you deploy it to some ephemeral environment and it gets tested so that your changes get tested. That test gates it before it even hits QA. And then QA can take the time to really hammer on it and mess with it and see if they can find out where it's broken. And then QA can then add acceptance tests before it hits staging. And then staging is where all the changes get all put together before it goes off to production. So there's a lot of different things here for the various bits and pieces that you can use staging for. Okay. In fact, let's prove that these are two separate stacks by running a Pulumi up. We're going to discover that staging, hopefully, is going to actually show different things. So you'll notice that the plan actually says it has to create these things. So yeah, let's perform the update. Let's see what it does. So it's creating all of these things new. Remember, we still have the other stack standing. So while this is standing up, let's go back, take a look. And hopefully, as it's standing up, let me give it a chance to actually stand up before I go check the actual instance page. Is this a competition for Terraform? We talked about that a little bit earlier, shortly. Yes. There's probably some things that you could actually have standing up next to each other. You could have a Terraform stack and a Pulumi stack, and both of them can be running at the same time. Pulumi can consume Terraform state. So if you're familiar with Terraform state, Pulumi can consume that as part of moving over to Pulumi. Lots of different things happening there. My instance is still, there it goes. And you'll notice, hey, look, the endpoint's different. And they're both here. Now, you can certainly change this name. I think this is the display name, I think is what I had this down as. Or Raul wrote a lot of this code for me, so props to Raul for a lot of this. In this case, I think it's the display name. Yeah, so the display name says the same thing. If I were to leave it alone, it should actually take this instance Oracle Linux and start adding key a random string to it. Polumi does that so that it doesn't in staging it doesn't actually coincide, or it doesn't conflict. There's the word I'm looking for. So yeah, so that's just something to know about how you can use different stacks to build different bits and pieces of your infrastructure so that it actually works. And you can stand up a test environment, a staging environment, things like that. Before we do anything else, I do want to tear this down. So something to know. We have a command called Pulumi destroy. Pulumi destroy takes down all of the various bits and pieces that you put up. It keeps track of everything through state, and then it tears it all down. Oh, you know what? Before I do that, let me show you what that looks like in the service, where we have two different stacks. So here I am in my project, and then we have two different stacks, dev and staging. And I can track the state of those differently and what's happening on each one. Can you have hundreds of these in this project? Yes, if you are willing to pay for that much cloud resources. No judgment here, like that's your choice. But if you were running, like, let's say lots of different testing, various bits and pieces, you will see a whole bunch of testing stacks here. So just something to know. All right. So with all of that in mind, let's run a Pulumi destroy, tear all this down, and then we're actually going to go try some Kubernetes. Y'all ready to do that? Pulumi destroy pulls down all of the resources, but it leaves up all of the configuration information for the stack. So, you know, let's say you're noodling on something, you're trying to see if you can get it to work, you're kind of poking at your code, and you just have to tear it down because for some reason you just can't get it to work the way you expect it to. That's okay. That's what this does. You can tear it down, keep the configuration so you don't have to set everything back up again. It's already up there on the Pulumi engine and ready to go. And then you can just run another Pulumi up. One thing while this is going, I do want to address the issue of, let's say, a resource hanging when you're trying to do an update, a delete, anything along that line, and suddenly your state in Pulumi doesn't match the state of your cloud resources. It happens occasionally, especially if you're like me and our internet just goes out at random times because it's hot here in Austin, Texas. Sorry, it happens. So sometimes I'm in the middle of doing something and it tears down. Now, mind you, the destroy, it might still be going on because it's running on the engine, not on my local machine. But occasionally my machine hasn't sent the right commands yet to the engine to be able to run this. So in that case, we have a command called Pulumi refresh, which updates the state file based on the current cloud resources. And occasionally you do have to go in and just tell it to remove a specific component or resource from your state file and start all over again with it. It happens. Don't panic. We do have a troubleshooting page on Polumi.com to help you get there. So in this case, staging is deleted, but you'll note that it's just the stack. If you were to go back here and take a look at the instances, and we'll refresh my page here, pardon me, we'll actually discover that there's one terminated, but there's another one still running. So in this case, that's my dev stack. So I need to go over and let me clear this so you can see what I'm doing. So it's not the bottom of your terminal. I'm going to do Pulumi stack select dev, and it's going to switch me over to the dev stack, and I'm going to run Pulumi destroy again. Okay. There is a -y flag if you're impatient and you just don't have to keep hitting yes. I'm doing that just so that you can see what it looks like. But if you do -y, it does the preview, then immediately says yes and runs into the delete or up, depending on which command you're doing. So Pulumi up -y, Pulumi destroy -y, both work. Okay, so once this is done, we're going to flip over, and I'm actually going to let this one run. And I'm going to do one little thing off screen here so you can't see what I'm about to do. And we're going to try a different build. This is a different project. If you're running this locally and you're on part 3 now, number 3 of the workshop repo, you're going to be copying over this exact code. I'm leaving it here because I already have all the configurations set up. I don't want you all to have to continue to watch that. And this one's going to take a little while to deploy. If you've ever deployed any resources here on, clear. If you've ever deployed any resources on, yep, there it is. This is the correct one. Okay. If you've ever deployed a Kubernetes cluster on OCI, you know that it takes a little while. It takes a little while in any cloud provider because there's a lot to stand up if you've ever stood up your actual cloud provider. So we're going to go into this OCI workshop build. And this is, let's see, OCI workshop build. There's a lot going on here. Now, you're going to find out that I've deployed this quite often over the past couple days just to make sure. I believe I ran a destroy last. Yes, so my destroy did run. This actual build is something, what I want to show you here with this build is there's some extra things that you get to do because you are using a programming language. And let's first run, I'm going to delete this old kube config here before I forget. And again, I want to give a quick shout out to Raul for making this code. I've changed it a little bit. I apologize in advance, mostly because I prefer to use a lot more variables and various different things, but you'll see that the skeleton of the code is there. I've collapsed a couple things, but this, let's get rid of that. This is where we can start talking about outputs. And let me first get this thing started. All right, that's going to take forever to run. It's going to do a quick preview, but let's collapse the project down. I'm still going to have to shrink this over. So see, there's a lot of stuff running. All right, we're just going to hit yes, and we're going to let this run. Okay, that's running. Let's talk a little bit about what's happening here on line 311 and 312. You'll notice that I have this little apply call. Polumi's resource management system, so like building up all of these resources, relies on asynchronous what's the word I'm looking for today? I'm so sorry. Asynchronous commands running so that each resource is actually getting built at the same time, unless it depends on something else. So as a result, this actual get cluster kube config call, this function, would try to start running before the cluster is actually created, and then it's going to fail. So what we have is something called applying an output, so that we're actually waiting for the promise, or the asynchronous command, waiting for that promise to finish. And then it's taking that output and applying it to my command. This is one of those things that is a little hard to wrap your head around at first if you're new to this. But the idea is that this allows infrastructure as code to be extremely powerful. You can wait for information, you can grab it from what's there, you can build new strings, you can send it off to output. This is the inside the program version of the Pulumi stack export, basically, if you want to think about it that way. This is how we call that promise and wait for that promise to complete, and then apply that to something else. There's a bunch of different ways you can actually do this. I like .apply because it's useful for me. If you were building a string, you would do .concat in Python. There's a .all, which allows you to use an array or a list of various values that you can build up. But in this case, I'm specifically saying I want to get this cluster ID and apply it to getting the cluster kube config, so that I can actually pull that up and see. You can see the type hint just came up. And then I'm going to take that information and I'm going to apply it, and I want to save it to a file, which we're going to then use to actually go interact with the cluster using kube control or kubectl or kubectl, depending on how exactly you want to say it. I say it in 3 different ways. You can argue with me in the comments, because it's gotten very, very quiet in the comments, which one you prefer to use. But I wanted to highlight this one because a lot of people get stuck here. A lot of people want to try to learn more from this little piece. So let's see here. We're going to get that information, and we're still waiting. Yeah, you can do the alias k equals kube control, kubectl, kubectl, whatever you want to say. I know. I'll be honest with you, as somebody who writes a lot of this for people watching me, I don't do that. It's mostly because people have trouble if they're new to it. They kind of go, what's that? I still remember the first time someone used LL in front of me, and I was so lost. Because I didn't know what LL stood for. I then learned it was ls-la if you're actually listing what's going on. I've gotten back into the habit of using LL on workshops, and I apologize for those of you who saw me do it earlier and I wasn't thinking. Generally, I try to actually type out all commands, because I think a lot of people get stuck because they don't know what the flags mean, or the aliases, or the shortcuts, or things like that. Anyway, oh, I know what else I wanted to talk about while we're still waiting for this to keep building. This takes like 15 minutes to build, so don't panic. It's okay. The thing I wanted to show you was, pardon me, this require secret and require secret, get secret. You'll see some various forms. When you are running config dot whatever, or Pulumi.config dot require, etc. This is how we, again, pull information from this file, this Pulumi.dev.yaml. If you were to say, and I don't want to type on here, but if I were to write down config.get open parentheses, close parentheses, secret. So let me actually do that here. If I were to write config.get, and then I say region, the difference of that between, let me again make this bigger, that versus config.require.region. Config.get says, check the configuration file, can check the configuration that you have in state, and see if it has this field region, this key. If it doesn't, return none. That's what get means. Require says, hey, check the configuration file and the configuration information for this key region. If we don't have it, fail the build and tell us that we're missing it. Now, why would this matter? Let's say that you are doing testing and there's maybe a field that you want to add in that's like a flag or some little something that you want to use as a tag in all of your names that just says, this is for QA, don't take mine, don't take this. Or I know one of the things that I've seen some teams do, some smaller teams, they actually put in your name as a configuration value and they put that into the actual name that Polumi gives it so that they can say, oh, okay, Laura stood up these instances. I need to talk to her before I tear them down. Or, you know, Pat put up these ones. I need to go talk to him before we put them down, right? So those two scenarios might be a case where you might just want get. Generally, I just use require because half the time that's why I'm using a configuration value in the first place. I want to require some things that are needed. But it's up to you how you decide to want to do that. Just think through, why do I need this value? What's it being used for? And if I get none back, is that okay? Maybe it is. You'll have to find out. You might find that especially with Booleans. So if you're doing a true false, maybe it not being there is okay. Who knows? What else can I tell you while we are waiting for our stack to stand up? Let's see, how long have we been running? Still creating, we're on the cluster now. We haven't gotten to the nodes yet, right? Right. Okay. What other questions do you have for me about Polumi? Has anyone used Polumi before? Are you stuck anywhere? I think some folks were asking about, do Oracle teams use Polumi for OCI? I don't know. I don't know what else people are running right now at Oracle, but 8 minutes ago, we still have a few minutes left here on this specific build. Well, I'm double checking my notes to see what else. What else do I have on here? Let's see. So there are some ways to convert things to Polumi. How did you? Okay, so hold on. Let me first, before I do that, I got two questions in here. How did you get the Kubernetes code that you're running, VCN, OCIDs, and all that? That's a great question. We posted this a little bit earlier, but we're on part 3 of this repo. So let me just drop this in the chat. So that's where we are. I already had this kind of up, thanks to Raul, who kind of put this all together. One thing when you're kind of creating this is you have to understand a little bit about the architecture of what you're trying to build. There's a lot of really wonderful resources out there that help teach what pieces you need to put together to make something work. Oracle actually has, and if someone can drop like the blog post maybe that has the architecture that explains everything behind the Kubernetes one that we're running today. Because I remember there's like a diagram that explains a lot of bits and pieces for that architecture. Generally, if you're thinking about a Kubernetes cluster, there has to be some way for the cluster to get built. So that's the nodes, which are your instances, and the actual cluster itself, like how that's put together, which has all your pods and all that fun stuff inside of it. And then you need your, and that's also with a manifest, which is buried in here. Let me go show you what that is. Resource, nope, manifest. This deployment spec is what it's actually deploying for the cluster. Oop. So you'll be able to actually see here. This information is like basically pure Kubernetes. So you'll be able to find all of that information there. So hopefully that gives you a little bit, but you need the cluster, the nodes, a network of some sort. Often most cloud providers require also some security rules to be able to make things work, to access it from the internet, etc. And then in this case, I have a container repository. I don't have anything in there right now, but you could use like, we're going to run out of time before I get a chance to show you the Oracle DevOps side. But if you were running a pipeline, the pipeline can then put images in the repo, and then the repo can be the source of the images for your cluster, and you can build a whole thing from there. In this case, we're just having some gateways and security lists and subnets. Subnets are going to be part of your virtual network to be able to actually access the internet. So that's where all of that is coming from. So hopefully that was a very, very, very quick overview of unpacking Kubernetes a little bit. If you're sharing a stack via Git, does each person need to update auth config inputs each time before they update? I'm not 100% sure if I understand the question, but I'm going to let me rephrase the question as I hear it. If you are sharing your Polumi program and your Polumi project with other people via Git, how do people set up configuration? So there's a couple ways to do it, but all of that basic stuff about your specific user is going to have to get entered in yourself, because you're the only one who has those access keys. But if you're sharing all the other stuff like the region, or if we were to go digging around in this one here, I'll just point the specific one out, which is not currently being used, but this configuration on line 4, you can share this dev.yaml file as part of your Git repo, and they can pull that data in. I can copy that line to another one, and I just have to change the namespace. In my case, the namespace is OCI-workshop-build. You could copy it over, and then the next time you run Polumi up, it updates. I'd say like the best way to do it though is to do it through a pipeline, because the pipeline then has all the configuration and it doesn't change. So if you can do any kind of like bot account or something like that, it works a little better. But that kind of depends on what you're doing. So I think I understood your question. If that wasn't the question, let me know. But, you can also copy the configuration from one stack to another. I think we talked about that briefly. I showed you when I did the Pulumi stack init, and I copied the configuration. You actually can do that as a project or pull directly from a project. So let's say, there is Pulumi config set all. Let's go back. And load it while we're still waiting for this thing to come up. This Pulumi copy lets you copy from one stack to another. So you can copy it from one stack to another, and it should actually move all the secrets over as well. Just be aware that if it's your personal thing, like your user information, you're going to have to change it. So that's kind of the one big thing. But like, if you know, for example, that there's always an SSH key on this part of your cloud, you have it in a bucket somewhere, maybe like an object storage. Maybe you pull down from that, something from that. That might be a secret that you can just pull from. Good question. Let's see. Has it started yet? No. Okay. I can hope. It does take a little while. I think the actual Oracle docs say go get a cup of coffee, come back. But hey, we're onto the node pool, so that's good. And normally this thing takes about 17 minutes on my internet. We're about 15 minutes. So we got like 2 more minutes to go. What else can I show you here on the thing? Oh, here's the diff, by the way, if you want to be able to see that diff. Oh, you know what? That's the one thing I didn't show you. And I probably should have, but we're now waiting for this build to complete. If you actually change only one thing, like let's say that you realize that you want to change the name of your container repo for some reason, right? The display name. If I were to then run this Pulumi up command, I'm going to get an update, not a brand new creation. Polumi and any infrastructure as code system is smart enough, any infrastructure as code system that tracks state. That's the key piece. Anything that can track state. is going to realize that everything else is already created and still running because it checks it against the state and says, oh, okay, everything is the same except for this one little thing. So it's only going to update that resource. So prior or subsequent updates run a lot faster because you're not creating everything from scratch. You're only creating or updating the pieces that you need. So like if I wanted to first create the networks, I could run Pulumi up, the networks would get created. Then I want to add maybe like the container repository. That would then get added, but everything else stays the same. It doesn't get touched unless it's actually being changed. So if you're actually running a production system and you only want to change part of it, but leave everything else up and running so that people can still access it, you can do that without any downtime, which is really nice. Polumi does a create before delete, if I'm remembering right, when it actually creates new resources. So let's say that I do want to change this container repo for some reason. Once it's actually created and up and running, and say like I then want to change it, it's going to create that resource and then go through and delete the old one. It's not going to sit here and go, okay, let me tear down the old one, then no one has access to it. Everything's gone. Okay, good luck. Update your bookmarks. That's not going to work. So instead, it actually goes through and lets you continue to access the old one and then moves everything over. So if you're smart about your cloud architecture, you can set it up where, like, for example, a load balancer, you have a load balancer running and it's moving everything around while you change out instances behind it. So if you're doing something like that. Yeah, there's a lot of things there. We also have an automation API that lets us automate some things. Has it finished? No, not yet. Oh, hey. Oh no, that's the previous one. Whoops. I hit previous. We also have an automation API that you can use to write Pulumi programs that lets it run within pipelines. So if you were writing it into your application, that it actually goes through and stands stuff up. So if you're a platform engineering team, works great. Other than that, Polumi can also take in a lot of different things from other infrastructure as code tools. So if you go to learn.polumi.com, we have this migration and imports pathway that goes through how you can actually bring in resources from other places. So we have a way to import it from a CLI, import it in bulk, and import it via code, so that you can actually leave something up and running and import the state of that resource along with the code into Polumi, so you can start managing it with Polumi instead of whatever system you used. Or let's say that you stood everything up on Oracle Cloud through the CLI, or maybe you were going through and making it on the actual console, and then you want to actually break that out and start managing it with Polumi. You can do that. So I highly recommend going through and trying this out to walk through this specific pathway. I did write this, so maybe I'm a little biased, but if you have any questions about that, always happy to answer that in the Polumi Slack. Let's see, did it actually finish? No, not yet. All right, any more questions while we're waiting? Do we have Polumi code to clone a VM? You mean you want to take a VM and do the same exact thing on another stack? Maybe like another environment? If you do that, you're just running the same code. So if you already stood it up with Polumi, you just run the same code. Oh, hey, there it is. You would just run the same code and go through and just put it up on another stack. Or you can copy the code, paste it below it, change the name and do that. So that also works. And you can then have two VMs that are exactly the same, two instances. Hopefully that made sense. Let's check this out. So cool thing is that it generated a kubeconfig file. Let me open that. And we can see here it is. This is our generated kubeconfig file. Remember that apply where we were applying the outputs. It applied it to this file right here. There it is. And so then I can actually run. Here we go. So kubeconfig generated /kubeconfig, which is this file right here. So there it is, my sandbox generated kubeconfig. And I just want to get the nodes. So I'm just going to ask Kubernetes, hey, what nodes am I running? And give it a moment. And there they are, all connected and ready to go. So we can see all of that together there. And that's kind of the big ones to show you how exactly this works. Let me actually, real quick, this is the one I haven't tested because I didn't actually remember to put this into my thing. But remember how I was saying, like, let me show you what happens if I just change something. Let's change the name of this, the display name. We're going to do -1. And I save the file. Hopefully it's saved. There we go. So we're going to clear this. Clear. There we go. Now, if I do a Polumi up now, only one thing changed. So we're expecting to only see one piece updated. So should say replace. See that replace? Diff display name, 1 to replace, 15 unchanged. And I can just see the details here, and you can see this is the only thing that's changing. Now it actually has to get replaced, but that's how it works. But see? Pretty cool diff right there. So if I just run yes and run up, it should just change the actual container repository information. And it should be a very much faster build. Done. And there we have it. So that's just to give you a quick idea that the only thing that actually happens is only replacing the things that you need to see. So in this case, this update, we can actually see it tells me 15 things unchanged, 1 resource updated, and there's the timeline. The configuration is the same, and my environment. And I think this one, did I have anything dependent? No, I didn't. I was going to try to show you that, but I think I forgot to do that. So with that in mind, always the best thing to do is to always tear down your environment if you're just running a basic thing here, so that you don't get charged on that free tier while you're trying it out. But if you're running prod, please don't just run Pulumi destroy on prod. Have I done that? Maybe. It's not a good idea. So on that note, this is basically the rough outline of today. I think we got a chance to see everything. I got the little screen sharing thing in my way here. There we go. So let's get back here to the slideshow. Please continue your journey with Polumi, continue your journey with Oracle Cloud. There's some more workshops from Polumi at polumi.com/resources, polumi.com docs getting started. We have a whole bunch of examples, and explore the OCI provider in the Polumi registry. Just go to polumi.com/registry/packages/OCI. You'll get a chance to take a look at the overview of the actual package, information about installation configuration, and you'll see in the configuration that you can do environment variables or configuration values. We used configuration values today. Environment variables do work. So if you prefer to do it that way, that does work. And then you can also explore the API. There's a whole bunch of different things that you can go check out with the OCI provider on Polumi. And on that note, and also there's a whole bunch of stuff from the Oracle DevRel team. Please go take a look at that. There's a blog post that ended up in the chat about actually taking a look at how you can run Polumi and Oracle Cloud together. And Tara just left a feedback link. So please do let us know what you thought of today's workshop. And there's some links about joining upcoming events. But thank you so very much. If you want to see me do more things with Polumi or any of my colleagues, we're on Polumi TV on YouTube. And hopefully we'll get a chance to talk soon. Thank you all so much for coming.